have to think about this. My wife's great-great-grandmother, I think that's right. My wife's great-great-grandmother was born in Denmark and died in Burton, Idaho, which is just across, it's just across the freeway from Rexburg. So it's right around the corner. And she's right there. One of the oldest graves in Burton. She passed away in 1894, I believe. And so we went to go see her grave, learn about her family, and she has two grandkids buried next to her. Anyways, that's how we spent some of our Memorial Day week. Memorial Day was visiting cemeteries and listening to bagpipes. It was amazing. I don't know. Can anybody beat that? Anybody have more fun than visiting cemeteries and listening to bagpipes on Memorial Day? Working on the midterm study guide. Okay, that's up there. That's definitely up there, Trevor. You might win the cake. Is there cake? You were in a hot tub for Memorial Day? Wow. Like how many hours could you stand in a hot tub? It was only 2 hours. That's fun. Car problems on the way home. Classic Memorial Day. Yeah, that's right. That's always so. That's great. Good. That sounds good. Anybody else want to share with us, be a little bit open with us, a little bit vulnerable? Anybody sleep in all day? Yeah. Okay. Sleep's good. Sleep's good. Well, good. Good, good. That's great. Glad to hear it. Okay, great. Yeah, let's see. So where are we for the class here? I put together over this weekend, I put together a second study guide. So I don't know if anybody's seen that yet. I want to just make sure that everybody has access to that and that you can access it if you like. Again, where are we at? The midterm is how far away now? The midterm opens on a week from today. Wait. Whoa, the midterm opens a week from today. That's right. Man, it goes by fast. Let's look at that real quick. Midterm exam opens on June 3rd, 11:30 a.m. Why 11:30? I don't even know. Closes June 10th. It's due June 10th at 11:59. Yeah. So that gives you a week and a day, week and half a day. But yeah, so I just wanted to make sure you're aware of the second study guide. So I looked at that first study guide. Not that the first study guide is bad. The first study guide is what I used last semester. Chris would recognize this. We talked about this before. We went through a couple of examples, a bunch of content from the chapter, from the book. The second midterm study guide is a little bit more, I just want to open it. It's a little bit more, let's see, what's the word? Should I say detailed? I don't know if that's the right word. But it goes through some concepts and a little bit more examples. So there's definitely some overlap, right? It's not like there's no overlap. This one I thought is going to be helpful as well. So it goes into some more of that logic that we've seen and provides you some good examples. Here's a do until loop. Here's a for each loop. Loop logic, method versus property, practice problems, some final tips. So this is additional information in preparation for the midterm exam. Questions on that? Right there. I would say together is best. Yeah. There's definitely overlap, so they're not mutually exclusive. I wouldn't do one or the other. If you had to choose between one, I would say do the first one. I think the second one just gives you some more examples. Please. Excellent. Yeah, did you say you came up with 41 pages of content? Sure. Right. Excellent. That sounds really good. Yeah. Right. More succinct. Yeah. Cool. That sounds good. That's great. That's probably the most, um, sounds great. Sounds like you're going to be ready for that midterm. That sounds great. Good. Great. Glad to hear that as well. Okay, well, today's content is debugging and error handling, and this represents kind of the final content that we're going to have from a classroom perspective on the midterm exam. So after today's content, you will be enabled to, you'll have all the information you need for preparing for and doing well on that midterm exam. Okay, great. Any other questions about the midterm exam? Please. Yeah. Yeah, exactly. That's it. That's what we're gonna do today. Yeah, exactly, actually. Yeah, very good. Okay, great. So let's dive in here. Let's say a prayer. Any volunteer for a prayer? What is today? Peter's Day. Peter, would you say a prayer for us? Thank you. Father, we are grateful for today and the past, Father, please bless us and all that we need. Through him, Father, we ask that you be with us. Holy Spirit, amen. Thanks very much. Okay, just out of curiosity, give me on a scale of 1 to 5, how confident do you feel about the midterm exam in terms of, in terms of uh, confident? Not that you're ready to take it right now, but you feel pretty confident when it's time to take it that you'll do well, right? Like how well will you do on the midterm exam? 1 to 5. 5 is piece of cake. 1 is I may have to take this class again. Okay, I see. I see mostly 2s and 3s. Okay, I think that's reasonable. I don't know, Chris. Any final words, advice? Yeah, I think that's fair. I think that's fair. I think that's true. You have a little bit more warning. Yeah, potentially you got a lot of time. That's true. I mean, hopefully that's good. Great. Is it possible? Is it true to say that if you answer the question in like 30 seconds, it's probably wrong.
I what I would do ended up doing what I ended up doing right I went through and had it address first side and then went through it.
Smart. So you were doing it multiple times, making sure it was right, and then if there was any difference, you'd go back and check.
Also, one thing there can be errors in the code, not very
Like purposeful errors by design, they put errors in there to
very read the code.
they. I say they. Okay, great, good, helpful. Any other questions on the midterm? Does that increase your confidence or decrease your confidence? Nate, you're so practical. I love it. I think there is one in that. In the, I think there's probably like 10 or 12 problems that have that as an option. This code does not run, but I'm pretty sure that only happens once. I think there's only one problem where the code doesn't run. That's right. Only answer that one. Now you know. I just gave you a free answer, basically. Okay, great. Let's go to debugging and error handling here. Let's open this up then, and let's jump in. Here's the file that we're going to download. Today we're going to cover debugging and testing VBA code. This is a pretty big one. Error handling is a big one, right? The fact that we're going beyond macros now and we can try to debug code turns out to be pretty important. A lot of times what I've seen is that when you go into companies, they have a piece of VBA script that's been around for generations. You know, they have this old VBA code that's been sitting in this file for like 20 years. And and something breaks and you have to go fix it, right? That's usually where you have very high pressure, very high value added, frankly. Opportunity to create value is trying to figure out where is the problem here. In addition, it's in call it debugging, right? It turns out that a long time ago, there really was there's the story, kind of a historical folklore story. I think it's true that there were some people in a computer program. They were fixing a computer, and this is before screens and before mouses that were used. And of course, the way that computer was built back then is these wires would connect, and you'd basically redo the wires um, to make the computer work. And they actually found a moth in one of the connectors, and they literally had to take this bug out of the system to make the computer work. And so apparently one of the sources of debugging was literally removing error, which was taking out this moth, taking out this bug from the system. And they say that's where the word debugging came from, right? Which is this idea of trying to remove errors from the computer to make it work. So that's the story of debugging. So in particular today, what we have here is we have some data. This is some list of product list data. Have we seen these? I think this is new data for our class, right? I don't think we've seen this yet. I think we'll come back to this later on when we do user forms. So I don't think we've seen this in class yet. And this is simply some data that was scraped from a website back in, I think it was early 2000s is where this came from. We have some dog training and pet supplies. We have some pistol grips, fanny packs, gunsmithing. I mean, a whole bunch of stuff. Birdhouse feeders, just from an online store back in the day when, you know, the early 2000s, of course, that was the explosion of online everything. And so this came from back then. And it's got a product ID, it's got a category, it's in a particular department, a particular manufacturer, it's got a price, a name, it's got an image, the name of an image, and it's got some other information here. The idea of today, debugging, error handling, is we're going to talk about three types of errors. One type of error is a syntax error. So let me go ahead and put some notes in our module here, just to give you some basis for what we're going to do today. Three types of errors. So I'll put this in a comment. Three types of errors. One type is syntax error. And another type is a runtime error, meaning that's the error that we see when we run the program, right? We don't really catch it before we run it. We don't see it. It's not there. It's only when it runs that we get the error. And this third type is a logic error. And logic error are usually the hardest ones to debug because it's usually based on the computer doing exactly what we told it to do, but it did something we didn't anticipate, right? It did something incorrectly, and we don't know why it did it. Right, exactly. Exactly. Yeah, 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 exactly. So for example, this red line right there, what kind of this is an example of a syntax error, right? And I think everybody has, do you guys have red lines too in your when you download the file? I think so. This is an example of a syntax error. Can anybody find the error? Anybody see the error? It's red. It means that the interpreter here is saying, I I can't process this. There's something wrong here, right? This is not working for me. Yeah. Yeah, right until it's spelled wrong. Look at that. This is a classic do loop. It looks like we're doing something until something is blank. I mean, this is exactly how you'd write it. We've got this loop in here that works. We've got our loop down here. We've got our do events. All of this looks good, except the until word is misspelled. So that's an example of a syntax error because it can't process that. It's like I'm not there with you, right? That would be a syntax error. Um, and syntax errors. I mean, the nice thing is that there's a red line here. We can tell that this is an error. It turns out that not all syntax errors. So if I correct this word, it turns out that not all syntax errors are in red. So for example, if I took out this loop, this word loop, in fact, I'll just comment it out. Let's assume I didn't have it there, right? I forgot to put it in. It's not going to give me an error. Um, or excuse me, it'll give me an error. It's not going to give me a red line, right? If this is not there, if I forget to type that in, there's no red line here that says, oh, you have an error. But if I run it, it says do without loop. It gives me an error then. But this is also an example of a syntax error. So not all syntax errors have the red line, but it is still a syntax error, meaning the way the program is written, right? The actual letters on the screen, there's something wrong, please. Yeah, exactly. Just we didn't see it until we ran it. Yeah, that's an interesting one. Maybe a little bit of overlap there. Yeah. It's much more easier than that. It'll be pretty straightforward. The in the exam, it'll be like a red line. It's a syntax error. A runtime. I'll show you another example of a runtime error coming up too, and you'll be able to see. Oh, okay, that makes sense. But that was just to show that it is a syntax error because it's missing the loop. So I need to come down here and type that loop in, and then it'll run. Okay, great. So that is a syntax error. And there's a whole bunch of other syntax errors that you can imagine, right? If you can think of it, it's a syntax error. I mean, there's so many different syntax errors that you can have. Here's another interesting syntax error before we get to the other runtime and logic errors. If I come here below my do loop, my do events line, and if I type in this, if I type in if row equals 10, then do something. If I run this, I'm going to see an error. Let's see what this error is. This says loop without do. This is the same error we had when there was no loop, but now there is a loop. So this is this is where the error messaging in VBA is not as helpful as it should be in my mind. This is telling me there's a loop without do. But wait a minute, I have a do and I have a loop. And it turns out it has nothing to do with the loop or the do. That's it. That's exactly right. It read this if loop and it said, oh, you have a loop here and there's no do inside of this if. And so that's where that error comes from. But it really comes from the fact that you didn't have an end if, right? That would be how to fix that error, which is, oh yeah, I forgot to put an end if. So that's an example where, yeah, the error messaging here is not the best. Again, if I take out that end if, it says I have a loop without a do. The reason why it says that is because it sees the loop inside of this if statement and there's no end if, right? So that's another example um, of an error. And this, in some ways, this is an example of it's a syntax error because you forgot the end if, right? That's the syntax part. There is a runtime component that you didn't realize it until you ran it. And the fact that that's a hard one to debug. You have to think about that for a minute. You're like, wait a minute, I have a do here, I have a loop here. Oh, but my if does not have an end if. And then once you put that in, then the error goes away, which is a little bit weird. But that works. Okay, now, so let me show you a little bit more about the logic and the runtime error. Oftentimes, when we think about a logic error, one of the reactions that students often say, I've said this myself too, is why isn't it doing what I told it to do? You guys ever ask yourself that question? Why isn't the program doing what I told it to do? Yeah, over and over, a couple hours. Right. There's if you reverse the question to say instead of asking why won't it do what I told it to do, but ask what did I tell it to do? That helps you identify that the kind of the source of the logic error, right? Where did I tell it to do that? Right? It's really doing exactly that you tell it to do. Often the source of finding those logic errors is switching the question around and say, okay, where did I tell it to do that? And finding in the code where that happened, right? So logic errors can be the hardest to debug, and then there's runtime errors. Runtime errors, yeah, the syntax is correct, but when you run it, it doesn't work. So here is an example of a syntax error. So if I come up here and I say sheets, products, dot select. The reason why this is a runtime error is because there's no sheet called this, right? I've misspelled the name of the sheet. This is actually correct syntax, right? It's correct syntax in the sense that I have the sheets here, I have a string inside these double quotes, inside the parentheses, I have a dot select. All of this is valid syntax. And so it's not going to give you a red line. It validates, yes, this is correct syntax. It's a runtime error in the sense that, wait a minute, this says subscript out of range. And that's another one where the error message, I would say the error message is not the most helpful here. Just to give you a little bit of background on this error, the subscript's really talking about a little bit different kind of notation. So for example, if I were to come down here and say worksheets1.name, This is going to give me the name products, right? That's my first worksheet. This one is an index. It turns out this one is a subscript from the perspective of the people that wrote this coding, right? This one is a subscript for this collection of worksheets. They just couldn't do a little subscript. You know, in Word, you can do a little subscript, little small number in the bottom, shrinks it a little bit. So they said, hey, let's put it in parentheses and call it a subscript in their coding language. And so if I were to do worksheets1.name, that gives me the name of the first worksheet. What if I did worksheets subscript 10? That gives me subscript out of range. That's where that error comes from. There is no subscript 10, right? There's nothing like that. It doesn't exist. So that's where that error comes from, is that's the subscript out of range. It's saying, nah, there's nothing there.
So if you made 10 sheets, right?
If I made 10 sheets,
No, I mean like, yeah. So like inside of the actual cell, if you made 10 sheets, would there be a number 10? No. I'm not.
well, 10 is referring to the number of the sheet, right?
Yeah.
So that we only have 2 here. So I could do 2 works, but anything over 2 doesn't work.
Yeah, so if you inside Excel, like the Excel sheet,
Right.
made up of 10, and you put 10 in,
Yeah, that's right. We can name it 10 and it would pop that up. So the reason why this gives us that same error, subscript out of range, I'll run this one again. And it's talking about this, is because it can't find that sheet, right? It's saying, it doesn't exist. The error message is subscript out of range, right? It's the same error message, even though we're not using a number here, we're using a string and it can't find it, right? So this is an example of a runtime error. Again, syntax is correct, but this is a runtime error. Okay, so that gives us a little bit of an overview of these 3 type of errors. Let's see, is there anything else that would be helpful before we dive into some code here and do some error debugging? I think that's helpful. Yeah. Okay, great. So let's dive in here. The task that we want to accomplish here is a couple things. Today, we'll just do the first part of this. What we want to do is we want to create a couple of lists. Let's see, stand by here. And we want to make some lists. So what we're going to do in the future classes is we're going to edit some of this data using a user form. And what we want to do in preparation for that is we just want a list of all of the departments in this entire spreadsheet. How many rows we have? 860 rows. And I believe there's 4 different departments. There's general, hunting, outdoor, and apparel. And so instead of us looking through this entire list to come up with what these department names are, what the unique department names are, I want to write some VBA code that allows me to do that. So I think right now where we have the code.
departments there are inside of that.
Exactly. And I want to put that in a separate sheet. So I want to create another sheet and just put the number, just the unique names, hunting, what were the outdoor, general, and apparel.
Is unique one of the Excel functions that also work in?
No, we have to manually write this one. Yeah, it's a good question. Yeah, it's a great question. Unfortunately, no. Yeah. And this is probably with 4 of them, it's not that bad. With 860 rows, you could probably do that pretty easily without VBA. But if you can imagine, 1,000,000 rows of data, and you had 50 different departments or something to that effect, having this in VBA is going to make a huge difference, not just from a scale perspective. So that's kind of the task. So if I run this, let me take this line out of the code. And if I fix this until here, and if I just run this, what do we have here? We have process products. We are going to create a row variable. Row is equal to 2. Why do we want row 2 here? Yeah, that's right. Because we're starting row 2. We're going to void the header. Perfect. And we're in a do loop. So this is saying do until products. Products here is referring to the code name of the products sheet. Cells row 1.value. So we're saying cells row is going to be 2 the first time we do this. Column 1. So it's looking at column 1, row 2. And it says do this loop until that value is going to be empty. So it's going to go down here. And what is it going to do? It's going to print the row that we're on. And it's going to print the value of that first column, comma. It's also going to print column 6 from that row, which is 1, 2, 3, 4, 5, 6. It's going to print the name. So it's going to do the row, the ID, and the name. And it's just going to print it down here to the immediate window. And this is a basic loop. This is a great way to start coding, to just go down through every row, right? We've done this a couple times in class. So if I run this, and it should pop up. Here we go. All in the immediate window. We've got the row number, the ID number, product ID, and we've got the name. Okay, great. So far, so good. So what we want to do now is we want to use this as kind of a starting place to build a unique name of departments. So how are we going to do that? Let's see. Let's see. I think I lost my place. Where am I? Let's create a couple of variables. I'll come up to the top and let's create a column variable, dim call, C-O-L, as integer. And let's do dim found cell as range. The column's going to help us out with the getting over to the column. The found cell is going to allow us to find a particular department. Okay, great. And then let's come down to, let's see. Let's do this. Let's do, we're gonna have to create a new sheet. And we want to put these lists on a new sheet. And we'll call the sheet lists. That sounds fair enough. So let's come down here and inside this do loop, let's go into the debug. We'll go underneath the debug. And let's do this. Let's do oh wait, yeah, let's do this. Let's do set found cell is equal to worksheet lists rows. We're gonna try to find a department. We're gonna check to see if the department list has been set up or not. Yeah, you're right. I was just checking my notes. I was like, wait a minute, we haven't made the worksheet yet. Let's make the worksheet. Yeah, the first time we try to run this, it's not going to run. It's going to give us an error. In fact, that's why I did that. I'm trying to find in my notes why I did that, but that's why. If we were, bless you, if we were to write this first, I want to, bless you again. I want to show you what the error is, right? Worksheets lists dot rows. I'm going to look in the first row. And what I'm going to try to find here is the word department. And we've done finding before. So here's my find function at the end of this. So what I'm saying is set the found cell equal to worksheets lists, and that's what I'm expecting it to error on because we don't have a worksheet yet. On that sheet, look in the first row and find where it says department. And there's a whole bunch of options here inside the find option, bless you. I'm just going to ignore. So I have 3 commas in here on purpose, right? This is not a mistake. It looks weird, but that's my first option in find. And there's a couple of different other options here. I want to search for the whole cell. Everything inside that cell has got to be department. And that's why there's 3 commas here. I'm trying to get to that Excel whole option. So yeah, I want to search for the whole cell. Okay, so now when I run this, Notice the syntax is good, right? There's no red line here. Everything is within syntax. When I run this, it's going to give me an error. What's the error? Subscript out of range. That's it. Oh, you have a different error? Do you have a on this line? Oh, yeah, yeah. I think I did say worksheet, but then typed in an S. Yeah, so if I run this, it should say subscript out of range. That's referring to the fact that we don't have a worksheet named lists yet. So let's do this. So before this one, let's come and type in here. Let's say if sheet exists, and let's build a function here. I'm going to build a function that says sheet exists. So that's what I'm typing in here. And then if it exists, we'll do something. And I'll do my end if. So I don't forget to end my if statement. And so I've got my if statement here. If sheet exists lists, then do something. So let's go down and create a function. So I'm going to copy my sheet exists name. I'm going to come below my sub here, and I'm going to create a new function. And this is going to be a function procedure, not a sub procedure, because I just want to know if the sheet exists or not. I'm creating a function because, and this is also in the midterm, what's the difference between a sub procedure and a function procedure? A function procedure is you're going to do something with the data, right? I'm going to send it this name of a sheet, and it's going to return to me true or false. Does this sheet exist or not? So that's the difference between a function and a sub procedure. It does need input. That's right. So we're going to take input, and it's going to give us output. The name of my function is sheet exists. I'm going to give it some input called sheet name, and that's going to be a string. And I'm going to return a Boolean, which is true or false, right? I'm going to return true or false. So if I hit enter, that'll stop my break mode up here. That's fine. And it enters in the end function automatically. And now I've got space for a function. So inside this function, let's create a worksheet object. So dim, I'll do ws as worksheet. So I'm creating a worksheet. And let's just create a function that goes through all of the worksheets and tests whether this worksheet exists. So let's do a for each loop. For each worksheet in this workbook dot collection of worksheets, right? That's going to be my loop. And my end of that loop is going to be a next. So I've got the beginning and the end. For each one in this workbook collection of worksheets, let's start with, let's just debug print. Let's do debug.print. Give me what the name is. ws.name. Let's just do that, see if that works. And let me run this from my immediate window because I have to give it an input, right? So let's input sheets exists with the name products. And what does it do? Sheet exists products in my immediate window with a question mark there. It says products promos false. Okay, so sure enough, it's gone through each of the worksheets in the workbook. It's printed the name, products, promos, and then it gives me a false. It turns out that I haven't actually set the function to return anything, right? I need to do this at the end of the function. I need to tell it to return something. And so the default value for the Boolean return, if it's not set, is false. So that's where that false came from. This wasn't in my code yet, and so it just returned false. Okay, so this is good. So this means we can print each name. So instead of printing each name, let's do this. Let's do an if statement, and let's say if the worksheet name is equal to the sheet name that I'm passing in here, if the worksheet name is equal to this sheet name, notice it turned red. Why did it turn red? Because the syntax error. I'm missing a then, right? Then do something. And if it's the same, then I'll say sheet exists equals true, and then I'll exit the function. At this point, we don't need to continue searching because we know that there's only one sheet with that name. I don't have to keep searching. So I'm just going to exit the function. I'm out. See ya. No need to keep looking. This will allow us to check to see if that sheet exists. Okay, so then I'll come back down here. I'll come back to my immediate window, type in sheet exists products, and this time it says true. Let's just do a little, let's just do a neighbor check. Neighbor, where are we at? Tell your neighbor if you can get sheet exists products to be true in your immediate window using this function. Let's do that. You got false. Your sheet doesn't exist. It's a figment of your imagination. Oh, good question. Let me address that in just a second. Do you know why that might be false? Yeah. Kathleen? Jacob? Whoa, what's this? What in tarnation? Thanks for laughing. I appreciate that, Jacob. When you debug that, what does it highlight? Oh, it's up there. Okay. Were you running this one? Yeah, so we haven't created the sheets list, so that's expected, right? So if you stop that one, yeah. And then, but it's not gonna let you run it. You actually have to run it in your immediate window. Yeah. You're not. Okay, we've got an error, yeah.
So I'm still getting the same error for this one.
Oh, yeah. Then that's fine. We haven't actually created a list sheet yet, so click stop on that one.
And I'm trying to run this one separately.
Yeah, and come up to your immediate, yeah, click enter there. Boom, there you go. You got it. Perfect. Because it requires that input. That's why you have to do that. Great. We're good? You have a good weekend?
Yes.
Oh, good.
That's
You got some sleep. That's good. Okay, great. Peter got an error. And Nate, did you get this error too? You get false. And what if we put in here lowercase p? So if I put lowercase p for products here, what happens when I try to run this? Boom, false, doesn't exist. That's a problem. Kathleen, did you get this? You get true. See? See, guys? See, Kathleen's got this. Yeah, so let's account for that. So in our if statement, let's come up here and let's do a lowercase function. So I'll do L case, and I'm just going to lowercase this on this side of the if statement. So I'll put this ws.name inside of an L case function. And let's just lowercase it all, right? So let's just do lowercase on that side, and we'll do a lowercase on the other side. And that way, it doesn't make a huge difference if they capitalize or don't capitalize, right? We're just adding lower cases around either side of this if statement so that if I come down here and I do a lowercase p, it'll say true. Excellent. Peter's not here. Should we get on his computer for him and write some crazy VBA code and it doesn't let him save his work or something? Man, you guys are nasty. You guys are.
Hey, you're the one who thought of it.
Yeah, but you guys said yes. You're the ones that are okay with this. That doesn't give you. How do you sleep with yourself at night, Price?
I don't know.
Okay. He's like, yeah, I expected that. I expected that. It was my idea, but Price said yes. Yeah, so all we did to account for that error that we were seeing is we put a lowercase function in front of around ws.name, and we did a lowercase around the sheet name as well. So yep, it just makes the comparison lowercase. Yeah. Okay, cool. Okay, so now we have this function in sheet exists. Okay. Now what we can do is up top in our sub, it's going to run this if statement. If sheet exists list, if this is true, then we can run this set found cell function. If it's not true, we want to add it. Oh yeah, sure. Catch that. Yep, just L case on both sides of those. Yeah. So let's do this. Instead of just the if statement, if it exists, yes or no, let's flip this around and let's put a not in front of this. If sheet exists does not exist, so if that sheet doesn't exist, that's what this is saying here, right? If this exists, true, but if this does not exist, in other words, if it's true that it doesn't exist, right? That's what this is asking. We put a not in front of this function call. We just wrote this function. We sent it this lists, right? We can come down here we could change this to lists. And if this doesn't exist, it's false. So lists does not exist right now, but we're saying if we put a not in front of it, if it doesn't exist, then let's add it. So let's say worksheets dot add, right? Worksheets is the collection of worksheets. We're going to add a new one. We're also going to say dot name is equal to. We're going to give it a name right when we add it. I don't think we've done this before. Usually we have to create an object, a worksheet object, and then name that object lists. In this case, because we're adding it, we can give it a name right now. So this adding of a worksheet will return a reference to that worksheet that we just added. And we're saying take that reference and rename it to lists. Yeah, you can. You're talking about the code name. You would do that here in the properties window. No, apparently not. I've never done that in VBA script. Apparently the only way to do that is through, I mean, there might be a way. I've never done it. I wouldn't be surprised if there is a way. I've never done it. Yeah, good question. Okay, so we have an if statement now that says if the sheet does not exist, then we're going to add it and we're going to rename it to lists. Okay, great. So now we've got our sheet name. Now we can start to add some lists to it. Let's do this. So let me put a stop in here and let's go to this point. So I'll put a stop below my set found cell line and we're going to run this. And when I run this, what should happen? Well, it should go here. It's going to debug and print that first row. It's going to check to see if there's a sheet named lists. If it's not there, it's going to add it. And then it's going to do a search. It's going to try to find department inside of the lists worksheet, which is not going to be there, right? Because we haven't put anything in that sheet yet. And then it's going to stop. So let's run this. And sure enough, so it added lists to my spreadsheet. It printed, here's my debug.print, added the list sheet, and found cell. So here's an interesting one. So set found cell is equal to this. It went out and searched for department, didn't find it, and so it returned nothing. So if I mouse over found cell object with my mouse, it says found cell equals nothing. And this is true because it didn't find anything, but that's an actual property of this object. There's an actual property of this object called nothing. It says we didn't find it, so it's nothing. And what we can do is we can say, okay, if it's not there, let's add it, right? So now we can say, if I come down here and I say, if found cell is nothing, then do something. What am I going to do? I want to add it, right? So what I've said is go search for it. Oh, you didn't find it? That means found cell is nothing. Okay, then do this. Then we're going to add it. So let's do this. The first thing we need to do is we need to figure out which column we're going to put this in if it doesn't exist. And that's why we created this column variable up here. So let's create a column variable inside of this if statement. Call is equal to, we'll call the worksheets lists, and we'll say cells columns dot count. So we want to count all of the columns. And the reason why is we want to go all the way to the right. We want to go, it's like going all the way to the right column, X, what is this? Column XFD. And then we want to go control left arrow. And we want to go all the way back to the left to identify what is the last column of data, right? That's what we're going to do. So that's what we're telling VBA to do. But we need to know the total number of columns. So I want you to go all the way out to the right. So we'll say columns.count, and we'll just say row 1. We'll just hard code the 1 in there, and then come back. There's a code called end Excel to left in parentheses. So .end Excel to left, and that's like holding the control key down and pushing the left arrow is what that is. End to the left. So we want to go all the way to the left. That's going to give me the column with the last column of data, right? So if you can imagine, if we had multiple lists in this sheet, we had a department list, we had a product list, we had a warehouse list, a vendor list. We could go all the way to the right, come back to the left, and that would give us the last column of data. So that's the column that we want. That's the last column of data, but then we have to add 1 to go to the next column over, right? And that's what we want. So we want this column to be the worksheets, lists, and I want you to get, go to all the way to the right. Take the cell that's all the way to the right, the columns.count, comma 1, and then come back to the left. Say end to left, whatever that column is, that's going to be the last column of data. And then go to the right 1 column. That's the first empty column. That's where we want to put this list. Kind of a long line there, but that's a good one. So that gives us the column number that we want. And now that we have the column number, we can actually put in the title, department. That's really what we're doing. So I could say worksheets. I'll type in lists. That's the name of the worksheet. We'll do cells. This is going to be row 1, because this is going to be on the header row. And my column is going to be column. And the value of that cell is going to be department. So that's where I'll type in the header department on that column that we just figured out in the previous line on the header row. Okay, the other thing we need to add here is, what if it did find it? What if it did find department, after it exists? We can add an else if here. So I'll come over here to my inside the if statement, and I'll say else column is equal to found cell dot column. So in other words, if it finds department, tell me what column that department column's in, and just give me the column number, and it'll put that right there. That's inside the if statement. Okay, so let's try this. Let's do this again. I'll click on stop. Let me drag this, because I'm in break mode. It says break up here at the top. I've got this yellow arrow. I can click and drag all the way back up to here, which is pretty cool. That's actually pretty unique. In a lot of coding courses, You don't find this. Is that right, Carter? Carter's taken a whole bunch of coding this semester. Is there any other language you've seen where you can click and drag the cursor to go back and start to run from this line? Yeah, it's not very common. So I've just clicked and dragged the yellow arrow back up to this line that we can run this code. And one of the things that we can do from a debugging perspective is we can do this step into, and it's just F8. And I can run this line by clicking F8. So if I push F8, it'll run what's highlighted right now. So the yellow means I haven't run it yet. I'm about to run it. Tell me when to run it. And I can click F8 and it'll run that line. Yeah, good question. It's in debug. So if you click on debug, you have a whole bunch of options here. Hopefully we'll get through all these options today. There's step into right there. There's step over, step out, run to cursor. We'll talk about all these coming up in just a minute. But that's it. So we're going to run this line, and it's true because found cell is nothing. Why is it nothing? Because there's no department. We haven't put any department in that list sheet yet, right? So now it's going to run this line. I hit F8 again, and now I can mouse over. Column is column 2. So it's going to put it in column 2, which is perfect. I can do this. It's actually going to put it in. I hit F8 and it runs this line. And remember, it doesn't run the else. Why doesn't it run the else in this case? This is also on the midterm. The first one's met. It's mutually exclusive. That's right. You're going to do either one here. You're not going to run both. Yeah, exactly. And then I'll do the end if. I'll hit F8 and it takes me down to the stop. Okay, so at this point we have a list sheet. We have the department name in that sheet. And now we're ready to start adding what those department names actually are. Questions or comments? Okay, now we're going to run what's called an error trap. So sometimes when we write code and we have a logic error, a lot of times it's a logic error when we use an error trap. We actually write code to trap the error, which means we think there's going to be an error here, and we're going to trap it, which is kind of weird, right? Why would you trap an error? Why don't you just write the code so you don't have an error? That's a good idea. Oftentimes, if you remember going back to that time when we did the exercise where we were going to the internet and pulling information, what VBA can't do is VBA doesn't have, there's probably a way, I don't know how to do it, to check to see if there's a network connection, right? So if your network connection, you're not connected to the internet and you try to run that VBA program, it's not going to work. But VBA doesn't know that. It's going to go and then you're going to get an error, right? So oftentimes there are times when you pretty much know there could be an error if we run this code. And so we want to write some more code to trap that error. In other words, what do you do if you get an error? Don't just quit, right? Do this if you have an error. So let's do this. So that's what we're going to do next is we're going to trap an error. In order to do that, what I want to do is I want to comment out these lines up here. So this couple of lines that says if the sheet doesn't exist, then add it. I'm just going to comment these out. And again, this is to build the scenario where if the sheet doesn't exist, we'd expect an error and what to do in the case of that error, right? We're going to trap that error. So when we comment that out and we get an error on this line, right? So let me go ahead and stop this. Let me go ahead and delete my lists sheet and run this. And with these lines commented out, it's going to give me an error. What's the error going to be? Close. Subscript. What is it? Yeah, subscript out of range. That's right. That's right. That's because it's going to be like, wait a minute, we don't have this. There's no worksheet here. You want me to do something, a worksheet that doesn't exist. That's a subscript out of range error. And so what we're going to do now is we're going to say, okay, if you get an error when you run this line, do something about it, right? That's kind of an error trap. So one way to do this is saying if, let's see, well, there's two things. One way is to ignore the error. We could just ignore it. What if we said on air, resume next? And what that does is if there's an error here, it doesn't stop. It doesn't give us an error. It just keeps going. I mean, that's one way to handle an error, just ignore it, right? So if I go here, the secret of life, it doesn't even tell me there's an error, right? It's like, yeah, whatever. It just keeps going. And obviously that's very dangerous, right? There's problems associated with that. That can be very detrimental. But that's a possibility. Another way to do this is to say this. We can do an if statement. We can say, if you do find an error, then do something else. Notice when we run this, by the way, let me comment this out just real briefly and do this. Notice when we do, where's my error? There's my error. Notice when it says subscript out of range, it also says runtime error 9. It gives us a number. So back in the day when they were writing all these error messages, each type of error got a number to it. And this one is number 9. So one thing we could do is we could come in here and we could say, if you get an error, and if that error number is 9, then do something, right? So for example, if I come here after this line and I say, if error, and it's just ERR, which is kind of weird. If the error number is equal to 9, then on error, go to 0. And this is a weird one right here. This is basically the reverse. This statement is the reverse of this statement up here. This statement says on error, resume next. It's like, don't tell me about the errors, just keep going. This statement says, okay, fine, tell me about the errors. Go to 0 is like a reset. It's like, okay, if you get an error, fine, tell me about it. It's a weird way of saying that. This actually goes back to the old days of BASIC, Visual Basic for applications. Basic programming was a predecessor to Visual Basic. And back in the day, everything was lines. And so each line had a number. It started with 1. 1 was the first valid number, went to 100. And when you said go to 0, you're basically resetting this on this error one. You're resetting that error to 0. You're resetting it back to start, which is weird. I don't know why they did that back in the day. Probably good reason. Yeah, there's a space right there. Between the go and the to, no space here. Go to is one word, and then space 0. So this is, if this runs, right, and this would, we could uncomment this. We could say on error, resume next. This is going to ignore the error. This is going to run this line. It's going to find an error. What's that? Yes. And then it'll say, oh, wait, error number is 9. And then it will tell you the error down here, right? So we've turned off the error up here. We ran this code. There was an error. And then we turn it back on, right? But what we can also do here is we can say, okay, if, in fact, before I forget, I almost forgot to write my end if. Let me do my end if here. I almost forgot my end if. So I have, if the error number is 9, what we can also do is we can say, in fact, let me do this underneath this one. Let me go underneath this. So I'll do on error, go to 0, show me the error. But then worksheets.add.name is equal to lists. So this is another way to add that list. How about that? Through a specific error number. Right. Yeah. Without having to check to see. Yeah, exactly. Because we made a function here. Instead of doing that, we can say, okay, if you get this error number, just make it. Yeah. In some ways, it's easier, right? Yeah, just a couple lines of code versus a whole function. The challenge here is you got to get that number right? If you're looking for a specific error number and it throws for some reason some random different error number, then that might not work, right? That has a whole bunch of other Other problems. You know, another thing you could do here in that case is instead of equals 9, you could say does not equal 0. And that's saying if you get any error whatsoever, that would work as well. We'll just leave it as equals 9 here. Okay, great. So this is an example of trapping an error. We're trapping it, and we're going to react based on a specific error. Okay, great. Let's see. How are we doing on time? 20 minutes? Oh, man. Okay, so let's finish this example out here, and let's run this out so we can see. I mean, we still haven't actually created the list yet. So we haven't actually created the code that actually begins to type the words into the lists sheet yet, right? Let me just run this, see where we're at. Okay, this works. So if there's no lists sheet present, it will add the sheet. It then goes up and adds the department into the correct column. So we're doing good. So at this point, let's now start to add the department names. And let's do, let's do this. 4, 5. I'm missing, let's see, I think I'm missing one line. There it is. Yeah, we're going to use this find call again, but we're going to search for something else this time. So let's do set found cell. We're going to replace the found cell. We're going to do worksheets, lists, columns, whatever that column number is. And we're going to do a find, and this is the department column, right? So we're on the list sheet. We're in that column of the department. What we're looking for here is we're going to find the department of that row. We're going to try to find if that department is already listed. So we'll say products.cells row comma 3.value. So this is from the product sheet. We're pulling the third column of that particular row. And guess what that column is? That's the department column. So when row is 2, we're going to pull hunting from this sheet, and we're going to say, I want you to find it here in this sheet. So we're going to say find products.cells row comma 3.value. And we're going to finish out the find function here with 3 commas. We'll do XL whole to find the whole cell there. Let me make this a little bit bigger. There it is. So set found cell is equal to worksheets lists columns call. That's our department column. Find. It's going to search that whole column. It's going to say find this value. Find the hunting. That's what this is right here, right? For row 2, hunting is the name of the department in that column. Find it. I want you to find it. And if it's not there, so the next line, if found cell is nothing, then, and I'll do my end if, then we're going to add it. So if it's not found, in other words, if this hunting department from the product sheet is not found in the list sheet, then we need to add it. And that's how we do that. Worksheets, lists, dot cells, and we'll do rows dot count, comma column. So how many rows there are in that particular column. We're going to come up to the bottom one. So just like we went to the far right column and came back to the last data column, we're going to go now the bottom row. This is rows count on the entire sheet lists in that particular column. And then we're going to come up. So we'll do end Excel up. We're going to come all the way up to the last row in that column, right? The last row of data. That's what that says. End Excel up. And then we're going to go back down 1, and we're going to do an offset. Dot offset one row, same column. So 1 comma 0 dot value is equal to products dot cells, whichever row we're on, comma 3, which is the department column, whatever that value is. That is it. Whew. How about that? Isn't that beautiful? Whew. You feeling that? Man, oh, that's good stuff. Yeah, that deserves a stretch. If you have not stretched yet in class, you got to stretch your brain on this one. This is a good one. So what we're doing is we're searching. We're taking this hunting, row 2, this value is going to be the hunting department. We're going to look for that inside of the lists column where the department is in the lists. And we're going to find it. If it doesn't find it, so if found cell is nothing, then we're going to add it. So we're going to take hunting from the products sheet and put it into the lists sheet for the department column. We're going to go all the way down to the last row, come back up to the last row of data, and then offset 1 row and put the value into that cell. Whew! If you're reading that, if you can understand that, you know, even if you can't quite write it yet, if you can understand that, you are on your way to some pretty good VBA and debugging skills. Okay, great. Now, now we can run this. We can run this whole thing. So let me drag this back up here. We've got department already in our sheet. So we've already run this part of the code up here. And so I think we can just run play here. And if I comment out my stop, we should do it. So it went through every row, 861 rows, and it pulled all of the specific departments from all those rows into a specific list. Not bad. Not bad at all. Okay, how we doing? Pretty good? Oh, you got an error. What kind of error was it? A new error? Oh, it was. Okay, it's going through all the rows. That's good.
Mismatch.
Oh, interesting.
Oh, no.
Yeah, so it didn't write anything over here, but it went through all the rows. So your loop is still good. If found cell column is equal to cells, and this is the department. You got the department there. This is all good. Set found cell worksheets list column call. Find products cells row comma 3 value comma goes in Excel whole. What if you undo the stop? Uncomment out stop. So it stops right there. Run it again. And then mouse over found cell. Found cell nothing. Okay, so it didn't find anything.
But found cell equals nothing.
Then, okay, yeah, this is where it should put it in. Worksheets lists, cells, rows, count, dot, comma, column, end Excel up, offset 1 dot values, do the products, dot cells, rows. Oh, I think that's row. Because that's the variable up here, right? Row is integer, row 2. So that's the row. It was not finding that. Yeah. Now there it is. There's hunting. So now you can uncomment your stop and that should work. Yeah. Nice. What kind of error was that? No. No. Yeah. It did exactly what you told it to do, right? Rows. Do you have, in fact, do you have option explicit in the top? Oh, you do. So I wonder how it interpreted rows. I think that's a, I think that's a reserved word. Option explicit says you have to define all of your variables explicitly. If you don't have option explicit, you can just type in a random variable name in there and it will make an assumption about what you think it is, about what it thinks it is, and it will just run with it, whether or not that's what you want. And I was wondering if the rows was interpreted as a variable, but I don't think it was. I think it was a reserved word. So that's why I didn't know. Jacob? Subscript out of range, my favorite one. I think you spelled list wrong.
No, you didn't. L-I-S-T. Oh, the S. That's
Because I
what's
think when
going
you
on.
added it up here, I think you needed it with an S. And so now it didn't find it without the S.
What's
Is
that
that
one
right?
letter?
I know. Kathleen? Oh, Carter? Nice. Trevor?
Yeah, I got it.
Price?
Yeah.
Oh man, you guys are on fire.
One other thing that's all part of it.
Okay, he did the opposite. He put rows. He put rows instead of row. Look at you. Look at you. Okay, great. Questions, comments, concerns? We good? Let's see. Is this it? I can't. Let's see. Was there anything else on today? What else was I going to share? I think I might have finished. Is that true? Oh wait, a couple more things. Yeah, we're gonna do this debug menu. Let's do that. Okay, great. Perfect. So we got about 10 minutes. Oh, this is great. Okay, so one of the things that you can do that you might have already seen. Sorry, do you still need this down here, Branch? Okay. Is just like we can write in a stop here, we can also do left click on this gray bar over here. If I left click over here, it adds a little red dot, highlights the row red. This is equivalent to adding a stop. This is exactly like adding a stop in your code, which, I mean, it's what you expect, right? That little stop sign right there. So I can run F5 and it just stops. So that's kind of nice. We are now in break mode. So it says break up here. And we can come in down here. One of the great things about break mode is we can use our immediate window. Okay, what is row right now? But wait a second, it says row is 0. Why is that? Hasn't run it yet. Very good. So when it's highlighted yellow, it hasn't run it yet. If I hit F5 again, it'll run, and then it will change. Here's F8, and it runs that row. Now when I come down here and type row again in my immediate window, it's run that row. Row is now 2. So that's pretty cool. In addition, there is what's called a locals window. So if I come up to debug and click on, let's see, no, I think it's view. Yeah, view locals window. And this one's pretty cool, actually. This is a window that keeps track of all of the variables in your program. So here's row. This is view locals window. This can be pretty helpful if you're running some code and you want to know what the value of your variables are. So here's row, column, and found cell. Row, column, and found cell, right? These are exactly the variables that I set up here. Here they are down here. And based on where we're at right at this point in the code, row is 2. Column is 0. That's the default. We haven't done that. And nothing is the found cell. And if I keep running, if I do F8 a whole bunch of times, we can see that found cell gets set. There's a whole bunch of interesting properties of this found cell now. And column is 2, right? So we can see that through the locals window. These things change as we run the code. Just pretty cool. Another debug option is the watch window. So if I come up to view and I click on watch window, here is a watch window. And watch is pretty powerful because it gives us the ability to track not just variables, but like any kind of expression. And by the way, expression is on the midterm, right? Remember to look up what is an expression. But here's an expression. Here's an example. So if I do view watches and then I come up to debug and I say add watch, I can type in an expression. Here's an expression: range B3 dot value. Right? Range B3 dot value. That's an expression, and I can add that. I can click OK. And that will come down here. Oh, and look at that. The value is outdoor. So it already knows what that expression is based on my active sheet right here, which is lists. Range B3, the value is outdoor. So not only can I watch my variables from the locals window, I can also do a watch on my watches window. Range B3 value, that's an expression. And that evaluates to right now outdoor. I could also do this. So if I wanted to, I can come up here to debug. I can add another watch. Let's do a watch. Let's type in range B3 again, dot value, and I can say equals apparel. And then I can say break when value is true as a watch type. So there's 3 different watch types here. One is just watch it, just record it, just track it. Another is break when value is true. So I could write my code, run my program, and tell it to stop running when this becomes true, when B3 becomes apparel. In fact, let me change that. What's my B3? 1, 2, 3. Let me change that to outdoor. Probably a better way to track this. So when range B3 becomes outdoor, I want you to stop the code, right? I can put that in here, and now I can stop this. And let me go ahead and delete this, go back to my code, and now I can run this. And it should stop the code when my B3 value becomes outdoor. Oh yeah, I forgot about this. I'm gonna undo that one. Click on play. And there it is. So it stopped. It ran this line, and then it stopped. It ran the line. What's my row? Row number 53. So row 53 is what adds the outdoor department to this list. And this watch stopped the code. Okay, that's great. Let's see what else. Also in debug menu, there's the step into, step over, step out. And these are some really cool things. So if I drag this back up to, where was the one that we commented out? Let me comment these back into play here for a second. So we have this if not sheet exists function. And let me drag that, and here's what I can do. I can put my cursor on this line, and I can say, where to go? Run to cursor. That's an option. I can say set next statement, Control F9 to wherever my cursor is. And I can say, I want you to bring me back up to that line. That's pretty cool. I didn't have to click and drag my yellow arrow. I can just click on my line and do set next statement. I want to run this next. I forgot what I was going to do though. Oh yeah. So now that I'm here, and there's a couple different ways. If I'm debugging something, I'm trying to figure out where the problem is. And I know that this is going to take me to a new function. There's a couple different ways. If I step into this, what do you think is going to happen? It'll actually run down into the function, right? It'll step you into the function. If I go back, and let's say that I know that it's not the function, right? Let's say that I know it's not the function. So I want to go, if I'm here and I say, well, let me stop here. If I know it's not the function, let's see, remove, wait a minute. Oh, that's fine. What I can do is I can go over the function. I can step over the function. It's going to run the function, and then it's going to end up right here. That makes sense? So if I know it's not this function and I don't want to go into that function, I can do step over, and it will step over that function, which is pretty cool. Another one is step out. So if I'm in the function and I want to step out of the function, I can do step out. So I can do step into the function, and I'm in the function. And if I wanted to step out, then it takes me out of that function, right? It runs through the function, takes me out of that function. There's some other ones here. Toggle breakpoint. That's this is the breakpoint. I can toggle it with the menu. I can clear all breakpoints. I can edit my watches over here. And I can do show next statement, and it will show me where I'm at. So if I'm lost in the code somewhere, I'm down here, I don't know where the break is at, I can say, okay, wait, show me what the next statement, it takes me back up to what the break already is, where the yellow code is, or the yellow arrow. And then there's this one here called run to cursor. That's pretty cool. So if I come down here and I say, I want to run to this point, I can click on that. And it says an error, maybe because I haven't run it all. But that is another option, is to say run to your cursor. Okay, so those are some pretty good debug tools. Sorry, did we go over? Oh, we're almost over. Good job. Hopefully this is helpful for you. And this is it. This is the material that you need for the midterm exam, is in your hands and in your head. It's in your brain. It's there.
We gotta search, we gotta find it.
You got to find it. Now you just got to find it. That's it. That's awesome. Projects and homeworks. I didn't look at that. Do I need to take a quick look at that? Delete a worksheet today was the homework. Pretty straightforward. There is a project ISBN due Saturday. Chris, you're going to be out of town.
No, not this week. I was mistaken. This is it.
Okay, so you're going to be here this week.
So if you need anything, help with it, you know, like,
Awesome. Takes a little time, a little different than what we did in class, but that's a great place to start. Thanks, everybody. We'll talk to you on Thursday. It's different enough that you have to do some other stuff. Yes. It's different. It's different way to validate the number, right? Different steps, but the process you go through is the same. I completely forgot about that this weekend. That's terrible. I forgot to look on that. Oh, there's Andrea. What's up, Andrea?